Hello everyone, the topic for today is System and Surroundings under the course Basic Thermodynamics Part 1. But before proceeding further, I would like to introduce myself. My name is Harshit Agarwal, Mechanical Engineer, graduated from NIT Nagpur in 2008. I have cleared the Indian Engineering Services Examination. I have got the offer letter from most of the Maharatna and Navratna companies. I have cleared the GATE examination as well. Regarding course fee, there is no course fee as such, but you can always contribute whatever you feel like. You can also follow me on the specified link. Before going through this lesson, I would say that you must follow lesson 1, because in lesson 1 I have explained the word thermodynamics, and this is the simple definition of thermodynamics. What thermodynamics means is it is the science of energy transfer and its effects on properties of system. It is the science, it is okay, it is the science of energy transfer. What kind of energy transfer it is? What kind of energy transfer it is? And its effects on properties. What are the properties and what is system? So we will be understanding the system, we will be understanding the properties, we will be understanding the energy transfer and its effects on the properties of system. If you will understand these three words in detail, this is the first 4 lessons of PK Nag. But first of all, we will understand system, then properties, after that energy transfer. So now, system and surroundings. What is a system? A system is a region in space upon which the study is focused. For example, system is a region in space upon which the study is focused or concentrated. For example, the room in which you are sitting and listening to my lecture, my lesson, for that particular instant, for that particular time, that room is your system. And system till infinity, whatever it is surroundings. After system, whatever it is surroundings. Anything external to the system is known as surroundings. The room in which you are sitting for a particular time, the study is focused there only, the concentration of you is there only, so that is the system. And apart from system, external to the system is surroundings. And system plus surroundings together constitute what? System plus surroundings together constitute universe. So system plus surroundings is universe. There is one more term. What is boundary? The separation between system and surroundings is known as boundary. The separation between system and surroundings is known as boundary. This is a system. External to the system is surroundings, and the separation between system and surroundings is what? System boundary. So we need to understand this. What is system boundary? For example, the surroundings of your room, in which you are sitting, that room is separating you from the surroundings. The boundary of that room is known as system boundary, right? So if I'll ask you a simple question, whether this system boundary is always fixed or it is movable, right? In this thermodynamics topic, I'll be dealing with the cylinder piston arrangement examples. I'll be telling you all the examples with cylinder and piston arrangement, right? Note, system and surrounding together compromise a universe. ठीक है? Boundary can be either fixed or movable. It is a very important statement for objective point of view, both for GATE examination and engineering service examination. Boundary of a system can be either fixed or boundary of a system can be movable. If you are thinking how the boundary can be movable, most of the students will feel that boundary is always fixed. But I am telling you, boundary can be fixed or it can be movable. For example, this is a piston cylinder arrangement, right? This is the cylinder and this is the piston, right? And heat is supplied from the downward direction. For this system piston cylinder arrangement, this is the system, right? This is the system. For consider a gas inside this system, and heat is supplied to this gas, right? The moment the heat is supplied, the pressure inside the system will increase, right? The pressure inside the system will increase. The increase in pressure, what the increase in pressure will do? The pressure will raise the piston in the upward direction. The increase in pressure will raise the piston in the upward direction. So as you can see, this system has 4 boundaries. This left side wall, right side wall, and the low base. These 3 are what? Fixed boundaries. The green dotted line is a fixed boundary. But as you can see, the moment the heat is supplied, the piston will move upward. This red color is also a boundary, but this is a movable boundary. So the system boundary can be fixed or it can be movable. This is the system. Apart from them, whatever it is which is surroundings, there is a system boundary. The system boundary can be fixed as well as it is movable. Now, types of system. There are mainly three types of system. This is very important: closed system, open system, and isolated system. In closed system, there is energy transfer but no mass transfer. Keep in mind, there is no mass transfer in closed system, but yes, there is energy transfer. In open system, there is both energy transfer as well as mass transfer. In closed system, there is energy transfer, there is no mass transfer. In open system, there is energy transfer as well as there is mass transfer. And in isolated system, there is no energy transfer as well as no mass transfer. Nothing is there. No mass transfer as well as no energy transfer. Example of closed system, simple: cylinder piston without walls. I'll be telling you this example, I'll be explaining you this example in my next slide. In open system, keep in mind the examples of open system, because in numericals you have to focus whether a system is closed system, whether a system is open system. The formula is for an open system, the formula for closed system. These two formulas are totally different. For example, turbine is a open system, compressor is a open system, cylinder piston with valves is a open system. Isolated system, universe. System plus surroundings is universe. So there is no heat interaction, no energy interaction, no mass transfer. The universe, so universe is a isolated system. Hot coffee in a well insulated flask, it is a isolated system. Closed system, cylinder piston without walls. Open system, turbine compressor is a open system. Isolated system, universe, hot coffee in a well insulated. These are isolated system. Note: closed system focuses on definite quantity of matter. Matter is enclosed by boundary. As there is no mass transfer in closed system, so matter is fixed. Mass is fixed, so it focuses on definite quantity of matter. But in open system, focuses on definite volume, and volume is enclosed by control surface. Open system, there is energy transfer as well as there is mass transfer in open system, right? So it focuses on what? It focuses on definite volume, and volume is enclosed by control surface. This is open system, right? In closed system, there is definite volume. In closed system, there is definite matter or mass. This is the difference between closed system as well as open system. Now, I have told you, in closed system, cylinder piston without valve is a closed system, and cylinder piston with valve is a open system. Here I am explaining you that particular example. In closed system, as you can see, this is cylinder piston arrangement. There is no valves as such. Heat is supplied, energy is supplied, but there is no transfer of any mass. So in closed system, there is no mass transfer, only energy transfer. This is a closed system. But in open system, if valves are there, mass can transfer from this valve. There is an inlet valve as well as there is a outlet valve. So mass can transfer from this valve. Energy can also transfer from this valve. So in open system, there is mass transfer as well as energy transfer. So you need to be very focused. What is a closed system? What is an open system? Isolated system are very simple. They are mentioned. Isolated system is mentioned is in a numerical, but you have to find whether a particular system is a closed system or open system for solving the numericals. In my upcoming lessons, I will be telling you how to find the work done in different processes. But before that, you need to understand what is closed system and what is open system. There is a different formula for open system work done, and there is a different formula for a closed system work done. So we need to understand that very clearly, right? Thanks to all of you. Keep focusing on my lessons. This is Harshit Agarwal.